Hello, welcome to this video. In this video, we'll pick up from where we left off, looking at a few more examples of differentiation. So if we ask to find the gradient function of the function root x, would similarly let y be equal to root x, and let delta x be the small change in x, that causes y to change by delta y. And that would mean that y plus delta y is equal to the root of x plus delta x, because we have 2 points, point P, x, y, and the point Q, x plus delta x, y plus delta y. And what do we want? We want the gradient of the point PQ, which is delta y out of delta x. So we take y to the right-hand side. So this will be minus y, which is the square root of x plus delta x minus root x. It seems that we can't make any headway with this. But what we can do is rationalize the numerator, because this is silently the square root of x plus delta x minus the square root of x divided by 1. So if we could multiply the numerator and denominator of this function by the conjugate, so we have x plus delta x minus the square root of x times the square root of x plus delta x plus square root of x divided by the same thing. We'll be able to rationalize the numerator. So we'd have delta y is the difference of two squares. So this is the same as x plus delta x minus x out of the square root of x plus delta x plus the square root of x. And so delta y is equal to delta x out of the square root of x plus delta x plus the square root of x. What we want is delta y out of delta x. We realize that if we divide both sides by delta x, we'll have 1 out of x plus delta x plus x, both under square root, on the right hand side. Now what do we know? We know that as Q moves closer to P, delta x tends to 0. As delta x tends to 0, delta y out of delta x tends to the gradient of the tangent at P, which is dy dx. And therefore, dy dx would be delta y out of delta x when delta x is 0. It's going to be 1 out of the square root of x plus 0 plus the square root of x, which is 1 out of 2 root x. That's how we get the gradient function of root x. Okay. Let's try for a trigonometric function as well. Of course, this will need you to have some knowledge of of trigonometry. But same procedure to start us off. We let y be equal to sin x, and we let delta x be the small change in x that causes y to change by delta y. So this would mean that y plus delta y for point Q is equal to the sine of x plus delta x. And so delta y is equal to the sine of x plus delta x minus y, which is the sine of x plus delta x minus the sine of x. Now, at this point, you could decide to either use the compound angle formula to expand this, or you could use the factor formula to go with, a difference of sines. Let's use the compound angle formula. So this will be sine x cos of delta x plus the cos of x sine of delta x minus the sine of x. Now, for small angles in radians, this is a thing that happens when we're working with differentiation of trigonometric functions. For small angles in radians, and you could actually just check this out in your calculator. The cosine of delta x can be approximated to 1, and the sine delta x can be approximated to delta x, only for small angles in radians. And for that reason, differentiation is only valid for trigonometric functions for small angles in radians. So therefore, we can replace cos delta x with 1. This will be sine x, and we can replace sine of delta x with delta x. That would be delta x cos x, such that delta y is equal to delta x cos x. And therefore, delta y out of delta x is equal to cos x. Now we know that as delta x tends to 0, delta y out of delta x will tend to dy dx. Therefore, dy dx will be equal to cos x, since there is no delta x in the expression. And that's how we would get the gradient function of sine x. Okay, so what do we observe in general? Yeah, let's look at the algebraic functions that we've looked at. We had that for x squared, the gradient function was 2x. For x cubed, the gradient function was 3x squared. For root x, the gradient function was 1 out of 2 root x. So what would the gradient function be for x to the power n, generally speaking? Now, you might already be able to observe it, but let's see if we can prove what it would be. We let y equal to x to the power n, and then we let delta x be the small change in x. You know the phrase by now, such that delta y is a small change in y caused by that change. That would mean that y plus delta y is equal to x plus delta x raised to the power n. So delta y is equal to x plus delta x raised to the power n minus y. But you know that your y is x to the power n. Now from this point, we would have to carry out a binomial expansion. I believe that's the easiest way to go about it. A binomial expansion, so you'd have to know that as well, for x plus delta x raised to the power n. And so we know that that is the same as x to the power n plus n combination 1 times x to the power n minus 1 times delta x plus n combination 2 times x to the power n minus 2 times delta x squared all the way up to delta x raised to the power n, and then we're subtracting x to the power n. You realize that this leaves us with n combination 1 is n, yeah? So we can write that as n times x to the power n minus 1 times delta x plus n combination 2 times x to the power n minus 2 times delta x squared all the way up to delta x to the power n. And so remember, we want delta y out of delta x. So if we get that, divide all through by delta x, we'll have nx to the power n minus 1 plus n combination 2 times x to the power n minus 2 times just delta x now. And then the last term will be delta x raised to the power n minus 1. Now what do we know? We know that as delta x tends to 0, this term actually becomes dy dx, the gradient of the tangent. And you can see that if we substitute delta x with 0 in that equation, we simply just get nx to the power n minus 1. And so where you have the function y as x to the power n, its gradient function will be n times x to the power n minus 1, which you can see is the case for x squared, x cubed, and the square root of x. And so if we had, say, x to the power 5, I could go through the whole process of letting delta x be a small change in x and delta y be a small change in y that's caused by that, and finding delta y out of delta x, and then, replacing delta x with 0 in that expression. But because of this, I know that this would simply be that the derivative of this, which I write as d dx of that, is 5 times x to the power 4 because of this. And that's what we're going to be using going forward.